Good morning, ladies and gentlemen. Welcome to Build My Feedmill. Perrendale Publishers, which publishes the magazines of Milling and Grain, which you're all familiar with, International Aquafeed, and International Pet Food. And we work with VIV to host Build My Feedmill. It's sort of like a quick speed dating process. But before I explain that, we will all notice that most of us are speakers, presenters, and we have one or two in the audience. Hopefully we'll gain more people going through the 2-hour session. I'm recording this, video recording it. So for the speakers, if you stand around here, you'll be in the screen, in the recording, along with your slides. So we'll make these available as Build My Feedmill through our website that will be on demand. So please ensure that be aware that it's not just talking to ourselves. Okay, Build My Feedmill, as I said, is a bit of like speed dating. It's an opportunity for companies who exhibit on the show to make a presentation of 10 minutes on a product that they think they want greater awareness of. A technology that is improving feed production efficiency or lowering costs or saving energy. Anything that improves the lot of the feed manufacturer. But it is only one process in the flow diagram. So here's a flow diagram. The speakers have all selected an area they want to address, and we try to start from the beginning, raw materials, and work our way through with the speakers that we have. It's not every area is covered. So I'm pleased to say that we have a full program of 1, 2, 3, 4, 5, 6, 7, 8 speakers, and we'll have a short discussion at the end. I want to keep everybody to time. There's one company that is speaking a double presentation, and there's another company that just might go over the 10-minute mark that we're all abiding by. However, if we keep to time, we'll have 10 minutes at the end for a quick discussion about some of the points raised. And the speakers who do remain, we'll invite up here to answer those questions. But right now, it's my pleasure to welcome to the podium to talk to us about how a feed mill building design based on square silos can reduce building lead times. A very important area when you're developing a feed mill or installing storage facilities. And Wim Delamirio is from SCE. Their stand is on the exhibition floor, and you're quite welcome to visit them afterwards. But right now, Wim, the floor is yours.
Good morning, everyone. Thanks for introducing me. Thanks for organizing as well this conference. My name is Wim Delamier. I work for a company SCE, Silo Construction and Engineering. We are a Belgian-based company, and we construct actually square silo buildings worldwide. Myself, I'm responsible for Africa and Middle East region, and the topic of today is how will feed mill design based on square silos reduce a project lead time? So how will it help to realize your project faster and in time? So on SCE, we're founded in 1988. We're a family-owned company. We serve multiple industries, and we have executed over 800 projects worldwide. Today, we're about in 85 countries. In terms of industries, we work in grain and oilseeds, feed, food, and others. The topic of today is mainly animal feed, pet food, and aqua feed. So it's square silos applied to these 3 sectors. So I travel quite intensively over Africa and Middle East area. And actually what I see often in feed mills is these problems. On the one hand, I see buildings which have been built, but not having the process in mind. So they have been built often with too big of a footprint. They are based on round silos, meaning they have a lot of dead space inside the silo. It's difficult to keep them clean, and hygiene is of utmost importance in current business. Then secondly, if you look at the silos in the storage, often you see that it is silos which are not adapted to the product which is stored. So you see silos which have problems with mass flow. Actually, in a silo, you want to achieve mass flow. You want to achieve that products which goes in first goes out first. So FIFO, first in, first out. So we have problems in these silos, hang-ups, for instance, bridging as well, and rat holes. And these have huge costs, huge impact on the operations. Meaning you can have standstills, you can have product loss, you can have infestations. All of that is a big value loss for your project, for your mill. And then last, if I look at the installation or the installation of a new feed mill, we see often that there is a lack of skilled labor. Because for many of the feed millers, this is a one-in-a-lifetime project. So, and it's difficult to get really skilled labor on site. So this is actually, it's the three topics that the three problems that we like to address with our building method. So first of all, store more. On the left-hand side, you will see a typical building based on round silos. You see actually that there is a lot of space in between these silos, which has no use, no value. Also in that space, there is columns, there is beams, so you have to have a building around it. If you look to the right-hand side, you will see a square silo building, which is on the same footprint. And you see there is no space in between the silos. Actually, you have much more capacity on the same footprint. You have up to 40% more capacity and a much cleaner building. So what you see here is a pet food factory. Some of you might be familiar with it. It's in the UK. You see it's a block of silos. So the wall of one silo is also the wall of the other silo. You share walls. There's no empty spaces in between. The walls, actually, they are smooth walls. They are twin skin smooth walls, meaning that actually the wall is insulated. So it's very good for humidity. It's very good to avoid condensation. Also, if you compare to rounds, you can easily do other shapes. You can, instead of square, you can do rectangular and adapt to the process. And also, okay, this is a modular building. Let's say if you start with a mill maybe 25 tons per hour, but in the future you foresee an extension to 40 tons per hour, we can already foresee that in the initial design. So what you see here is a process building. You see that all the parts of the building are prefab. So we start with pre-engineering. We try to do as much as possible in our factories in Belgium, Germany, and Vietnam. Why is this? It's because what we do in a factory is in a controlled environment and has much better quality than what is done on a job site, where it's difficult to find the right skilled labor. It's also difficult to control the environment. You see also that the bins, they are actually a structural part of the building. So the bins, they are supporting the floors, they are taking the loads of the machinery. They are also taking the loads of the roof and of the cladding. So that's why we work together very closely with the process designers. So the process is always the basis for the design of the building. We never design a custom, we never design a standard building. It's always a building which is based on a certain process. And this leads also to lower cost of ownership, because as it is designed specifically as such, there is less dead spaces. We design it hygienically, so it's easier maintenance, and also it's designed to take, for instance, the vibrations of the machinery. Now in practice, this is a short movie showing, okay, how do we build a feed mill based on these prefab models. So we start with the foundation, then everything is bolts and nuts. Now on the left-hand side, you see a dosing block. So there all the raw materials will be dosed. These dosing blocks, these silos, come in panels. So everything comes in containers on site, which makes that we can easily install worldwide. On the right-hand side, you see the bulk outloading. And you see also that's the machine house, so which will house the process of the machine suppliers. That is carried, those loads are carried by the silos. And then, okay, you have the roof structure. The roof structure actually is also, the loads also go through the silos. And in the end, everything is cladded and ready for the machines or the process to be installed. Okay. So, if you compare this method, so the SEE building method based on square silos with a more traditional way of building silos, actually there is a very big difference. There is, on the one hand, you have the visible cost, which is, let's say, what you see up front, and then on the other hand, you have the invisible cost. And we compare this with icebergs. So the part which is invisible is often bigger than what is visible. So if you use the SEE methods, actually you have faster installation because you use prefab materials. You work with a small team. You are less depending on the skills of the people and on the conditions on site. Also, a lot of activities are in parallel. For instance, while the foundation is being done on site, in the factory, we are making all these prefab elements in order to install a building. Then secondly, if you look at the foundation, such a building based on square silos, steel structure is much lighter and has a smaller footprint than a traditional building. So you save a lot on civil costs, so on the foundation costs. Then the other thing is, okay, it's one supplier which supplies the full building. So if you have a machine supplier combined with a building supplier, you actually have a turnkey project. So it requires less coordination. From the building supplier, you will get a dedicated project manager who knows very well the specifics of this kind of building. And then, if you look at operational costs, actually the silos, they are designed for specific products, so they are self-cleaning, they are designed for mass flow. And also, let's say the building is designed to be clean and hygienic, so less maintenance costs and more operation time in your mill. So this is inside a square silo, a smooth wall silo. You see it is very clean. Actually, the walls as such, they are completely smooth. This is to avoid that product will stick to the wall. All the reinforcements which are in this silo, they are inside the panels or inside the walls of the silo. And then this is with specific hopper. We call it a mass flow hopper. I'll show the principle later on. This is a hopper to ensure that the product goes in and out in first in, first out principle. So this is the principle. Okay, so the advantage of round versus square, what you see now in yellow is actually the volume you have if you have a round silo. Now you see the volume if you have a square silo. So that's a difference of approximately 40%. Problem with badly designed square silos is this. Actually, the center of a square silo will flow faster than the outside. And this will lead for product to build up in a square silo. So this is called a funnel flow. It can lead to bridging. It can lead to a silo not functioning anymore. This is our silo, our hopper. Actually, this is designed for first in, first out. We have the same angle all around. There is no valley angle in the hopper. And now you will see both types of hoppers next to each other. So on the left hand, you have the funnel flow, which is what we want to avoid. On the right hand is actually is first in, first out flow, is what we want to achieve. So these silos then have a round outlet, and this gives you a lot of flexibility. Here you see an advantage, an example of a mill in Saudi Arabia. So you have a round outlet, gives you a lot of flexibility to move to the equipment which is below the silo. So you can turn 360 degrees and you can have the exact dimension of the outlet which is required. This is then in practice a mill which is built in Germany. You see on the left-hand side, you see actually the skeleton. You see the steel structure and the structural square silos. And on the right-hand side, you see the same building, but then cladded, which is ready to install the equipment. So thanks a lot for your time. Thanks for the opportunity to let me speak. So to wrap up, what is better with square silos? You have an optimum utilization of space, much more capacity on the same footprint. You install much easier and faster, and better hygiene in the building. If any questions will be later on, and then you can find us on booth LO56. Thanks a lot.
Thank you, very well handled, and some insight into how square silos might offer more advantages than our traditional round ones. I hope my microphone is working. Yes. I just remind speakers with the microphone itself, just stand a little bit away from it so we don't get the bounce coming through. You can hear it if you're standing too close. Okay, we move on to our second presentation, how to increase reliability and durability of your bucket elevator. This is by Justin van der Heuvel. He's from Muller Beltax. Justin, the floor is yours.
Thank you. Okay. Welcome. Thank you for being here. My name is Justin van der Heuvel, and I'm head of sales at the company Muller Beltax. Muller Beltax is a service and knowledge supplier for the bulk handling and process industry. Oh, okay. Did you hear me at all? Yeah? All right. We are a bucket elevator specialist since the 1970s. Not only do we supply components and spare parts, but we also do engineering, we provide advice, and do supervision on installation and the mounting of the components itself. Next to this, part of our core business is process monitoring systems as well as abrasion-resistant polyurethane lining materials. The knowledge is what we are often asked for, which is obtained by the supervision and the mounting we do. So thereby we know the process of the bucket elevator, and thereby we also know the flaws. The topic of today is how to increase reliability and durability of your bucket elevator. A bucket elevator is a critical part of the process whereby the belt, the elevator belt, the heart is inside this bucket elevator and key to an optimal process. In short, today I will explain some technical information about forces and frictions that are in play, and how to reduce your TCO, your total cost of ownership. On the right side or left side for you, you can see some forces at play, where, for example, the tension, the friction force, the digging resistance, driving forces. So you can see here that compared to a flat conveyor belt, the forces are much higher. They're about 10 times bigger than flat conveyor belt. So all of the weight, the belt, the buckets with the product in it, is hanging on half the circumference of your drive pulley. So this means that the construction has to be well calculated, and the belts that you will use have to be a different construction than a belt for a flat conveyor. On the other picture you see the flow of the material, whereby I will get to that in the next sheet. Let me see. So regarding the flow of the material, here you see an elevator with different angles of the inlet and the outlet. Whereas in the past, many bucket elevators were used for one type of product and a specific capacity, and nowadays the same bucket elevator might be used for different types of products with their different capacities. Because of this, you have to carefully think about how to construct your bucket elevator and what you need to adjust in order to reach this capacity. As I mentioned before, the elevator belt is the heart of the elevator, and basically all the components that come into contact with the belt are in a sense foreign objects that might do harm to a belt due to the pressure and the tension these parts exercise on the belt. So therefore, these attachments should be as light as possible in order to improve your operational safety and your belt life. The pulleys and the pulley legging should also be properly constructed and suitable for the type of belt and the operating conditions and the type of product handled. Next to this, in order to increase to reduce your total cost of ownership, it is advisable to use wear-resistant lining material. In this case, we would advise to use cryptane polyurethane, wear-resistant lining material inside the bucket elevator in the elevator head section, the inlet and the boot. Cryptane polyurethanes can be used in different applications, as you see, for the different types of materials, the different types of materials. For example, you have a specific hardness for sliding properties or impact resistance. Cryptane polyurethane is not only good for sliding properties, and it's also resistant to oils and fats, and important as well, is FDA approved. Then you have constructed your bucket elevator and you want to protect and measure your investment. You want to know what is going on inside. But this can be done by safety monitoring systems, whereby you want to monitor your belt misalignment, so you have the belt misaligning sensor. You want to measure the temperature in your bearings, where you can use the bearing temperature sensor and the speed sensor to monitor your speed, to check if the belt is slipping. When you install this, this is how you can prevent most optimally dust explosions. I will focus in this time on the belt misalignment sensor. This is a product we have developed. It's called the Rublock, and this is a fail-safe off-tracking warning device that is suitable for elevators handling higher temperatures as well. It's truly fail-safe because it gives a constant reading signal. If no signal is received, then either the device is not functioning or the connection might be faulty. The Rublock shows an immediate increase to temperatures due to the friction that is caused by the belt onto the block itself, onto the Rublock. Then you know it's off tracking. It also registers the ambient temperature. And you can also install a pre-alarm, for example 60 degrees, to run your bucket elevator empty, and a stop alarm at 80 degrees, for example. Well, all of this reduces your total cost of ownership. Your total cost of ownership extends your time between the maintenance stops and reduces your cost per ton of processed product. We have implemented this in 2005 for the end users, and as I said, it should extend the time between maintenance stops and reduce cost and control the cost. By monitoring the whole process, increasing the service life and time between maintenance stops, but also by maintenance planning, we do not only unburden you, but we often ensure there's a capacity increase or a cost reduction. Because the elevator is an enclosed conveyor system, the people who are working with it do not always see what is going on. This also affects the life of the belt in the long run and on the other wear parts as well. So important is that the people who are working with the elevator is to make sure that the elevator stays clean. This is also a very big help to increase the life of the moving parts in the elevator. For now, I would like to thank you for your attention, and if there are any additional questions or current issues, please visit us at Hall 8, and we are located at stand K41.
Justin, thank you.
You're welcome.
Justin, thank you very much. Very illuminating. I think for those who have joined us since we started, we're following the flow diagram of a feed mill, and we're picking on individual components in that flow diagram. So we're not dealing with them all, but the speakers from the exhibition hall have kindly come here, spent some time to explain some of their more advanced technologies. So now we turn our attention to save your grain in the store. This is a very important aspect of what we try to achieve. Quality of grain is very important to the quality of the end product, and I'm very pleased to say we have an expert in this field, Rolf Cobb, who is from BITEC, and he's going to address us on the subject of save your grain. Thank you, Rolf.
So thank you, Roger. Welcome, ladies and gentlemen. My name is Ralf Kolb. I like to talk about saving of quality of your grain in your store. You have seen before a good quality store, and you have seen good quality elevator, and now we have to look about the grain to save the quality of the grain in the store. You see here a picture from a farmer who like to have a good quality and a good volume. You see here a picture from a miller who like to have a good quality and a good volume, and what is between the grain lay in a store. And it's not like stones that you bring in the stones and after 1 year out or after 3 months out and it's the same stone. No, grain lives also after cutting, after harvesting, and gives energy and water to the air around and take off energy and water from the air around. So you have to look about your grain. I like to talk about grain store management, why cooling principle, advantages, and one picture from BITEC in Germany. You know, from FAO was published always around 20% of the worldwide harvest of cereals are waste in the storing time in the store. This is around 85 million tons, double number as in Germany is each year harvested. And it comes from insects, 80%, this is the main point, from fungi, and also 10% rodents and birds. About that you have to look. And this is the theoretical thing. Your grain is with around 69% carbohydrates, and these carbohydrates from the grain take off oxygen from the air around. You get CO2, this is not a problem, but water and heat is coming out. And this is the main point while you are storaging time. And so you have heat and water in the grain bulk. And that you have to bring to take out. This is the important point. If you do things bad, it can look like stacked. You see here your grain, it's like rocks, and it's at the end waste, and you lose a lot of money. So we come to the weevils. Maybe you know, if you have a store, you know this Cytophilus granarius, grain weevil or another one, and if the temperature is fine, they will come in your store, and when they are in the store, it looks like that. They eat your money. And from 2 of these insects, you will get, if temperature is in right condition, you get in 3 months, 1, 2, 3 months, 4,000. It's like an explosion. Yes, and they eat your money. That's that. I heard always this in the world, this is going on. And when we look about the temperature, we see the field beginning with 15, 20 degrees, the development starts. So you should store your grain lower than 20, better lower than 15 degrees. Because this is red field. Here you see the temperature on side left. In this red field is best situation for grain weevil. And the another one is like, I would say similar. Yeah, rice beetle, rice weevil like to have a little bit higher temperature. But when we look about the grain weevil, it starts with 15, latest at 20 degrees. So you should store your grain cooler. We come to the fungi. Fungi is, yeah, this picture. When you have very bad situation in your store, we come to this one. This is the theoretical point with Heim. Fungi comes from field with a grain in your store, the primary fungi or field fungi. And then in the store they change to the secondary fungi or store fungi. And the metabolism of the store fungi or secondary fungi are mycotoxin. So it can be that you get in your store while during the storing time you get more mycotoxin. So and here you see the most important, the 10 most important secondary fungi. We have to look about number 5. This is Aspergillus glaucus. Here, this yellow color about this. And you see, if temperature is lower than 20 degrees, here we have the temperature of the grain. Here we have the grain moisture content. And moisture content is lower than 14.5. Then you are in here white field, no secondary fungi, and from this no added mycotoxin in your store. And this is very, very important for all people in the world, all who eat grain, because mycotoxin are very strong. They are not dead after bakery of bread, because it's very stable, the mycotoxin, and you will have it also when you bake your bread. It's still in. But also you have to look about rodents and birds. Rodents I see everywhere in the stores. I'm traveling all the time in the world and see stores. Monitoring of rodents, it's done very well in each stores, but you also have to look about the birds. Here you see a picture from the Taiyo Mill in Fukuoka, Japan. You see here the green mesh. Here on the top is also a dark or a gray mesh. You cannot really see it, but it's there, I know it. And when here on site is a flat store, when a truck going in, they close always the mesh, so no birds can going in. Yes, take mesh and keep your store dark, then the birds will not going in. This is more a problem in flat stores than in silos. When we look about the cooling circle, at the end it's very simple. The cooler, you see here the cooler, take off environmental air. Equal if raining, snowing, nebula, hot or cold, no sense. The cooler take this air and produce a cold and dehydrated air. The air is now dry and cold and filtered. So, and then you need an air distribution system. Here you see a perfect air distribution system that the flow through the grain is very fine. And at the top, very important, you need windows, or nowadays always we have fans on the top of a silo or in a flat store. From our side it's not needed, but it's there, it helps a little bit fine. This fan on the top do not need a high pressure difference because he take only the air from the headroom to outside. No pressure difference, but same volume than the fan of the cooler. And the cooler have a lot of pressure, brings the air through the headroom or also outside. What does the cold and dry air do? The cold and dry air take off energy and water in the grain, and this is the point. And then you, after your grain is safe, because no insect population and no secondary fungi, and also not so much dry substance losses, but this is in this area not the big point. Here in this area are the big points, secondary fungi from that, from metabolism, the mycotoxin, and the insects. So what's going on? You have a store. Normally the grain comes with a temperature around 30 or 32 degrees. This is an example from Abu Dhabi, the big store in the Haber here. And you have here a cooler connected to the store. You set 15 degrees, and after the first day, on the bottom, temperature will be much lower. At the top, temperature is still high. Next day, a little bit more is cold. It's like a stamp. Goes the cold zone through the silo. 11th day, it's nearly finished with cooling. You have here a fine temperature, and you need one more day, and then the complete grain is cold. So, important is to clean, always to clean the silo before the new grains come, to clean the air distribution system, the elevator, and. This is very important. And against beetles, cooling, against meats, you need very dry grain, lower than water activity from 0.6. Against birds, gnats, and dark store, cats and dogs, keep your store closed, and rodents do monitoring. Yes, this is a picture, always the same situation, small cooler and very large silo. We do this business worldwide. In this year, We have birthday, 60 years, Granny Frigo grain cooler, who was developed in 1963 with the University of Düsseldorf in Germany. Yeah, this is our factory. And I come to the end. Grain is alive also after harvest. You can have problem, the process brings water and heat into your grain mass. Problems are insects and fungi, and the grain cooling is a natural solution. Many thanks for your listening.
Thank you very much, Rolf. Very interesting and intriguing about grain storage. Thank you. And your stand number?
Not in my head.
Yeah.
Hall 8.
It's hall 8 on the back wall. So please make, when you're out there, make your way to Triggertech stand and learn a little bit more about grain storage. Very knowledgeable company. Okay, so we're moving right on. We're sticking to time. We have a slight change in the program. FAMSUN is on your program, but they can't attend this morning, and so we've asked Joseph Barbie from ESE Intech. That's a Midland Investment Group.
Industrial group.
Yep. Who will talk to us about conditioning, cooling.
Drying and cooling.
Oh, drying and cooling. Okay, Joseph, welcome.
You got this.
Yeah.
Just use the arrows to go between the slides.
Yeah. Okay. The subject of drying and cooling. I'm Joseph Barbie from, like Roger said, from Engineered Systems and Equipment, part of the Midland Industrial Group, or now Midland ADN Group. We are at the US Pavilion. We've been in this business of building feed mills for about 45 years, and myself about 55 years. In every continent, I think I built 380 mills around the world. In the last 30 years, mainly shrimp feed, 22 in Ecuador. My wife is from Ecuador. Fish feeds, pet foods, and so on. And we could talk about the whole process, and I see there's nobody talking about extrusion and nobody talking about a lot of different, like Roger said, there's a lot of processes missing in the process flow diagram. But one important subject which I would like to talk about is drying and cooling. You know, I don't think many people knows what the difference is between drying and cooling. Yesterday a gentleman came and said, I need an extruder. But I already have a grinder, I already have a dryer. I said, okay, what dryer do you have? He said, oh, I make pellets, and you know, the pellets go into this machine and they come out dry. Well, that's not a dryer, that's a cooler, obviously. And there's a big difference. And one other thing which is important, I just came from Africa. We went at in Zambia, the African Aquaculture Convention, which I always go to everywhere in the world, and which was last week. And one of the big issues, I think, which people don't understand, what is your cost in the process of making aqua feeds or any extruded pet foods? Most people would think that your main cost is actually in the extruder, in the extrusion. And I'm not talking about cost of investment only. I'm talking about cost of processing, cost of production. And your main cost of production, of producing any kind of an extruded product, is in the dryer, which most people don't pay any attention to. And there's one law of physics which is also difficult to understand, and that is you need so many kilocalories or BTU to evaporate 1 liter or 1 gallon of water. Law of physics, no change. Nobody can do that better. Nobody can change that. It doesn't matter who the manufacturer is of a dryer around the world. What you can change is what energy you use in order to dry. So what is the difference between drying and cooling? Obviously, drying you use because your moisture is inside, in grain, in feed, inside to the center. And the only way to get that moisture out of that center from the product is to heat it and evaporate that moisture. The gentleman just talked about how important it is on the moisture content. I think 14% actually. I normally try to get it to 12% moisture for storage, but I think 14 is about the maximum you want to go, as you can see why. So what is cooling? Well, in the pelleting process, we don't get the moisture. We condition the feed and then we pellet it, but it evaporates because we are putting steam into that conditioner, and I think you're going to hear about conditioning here in the next couple minutes. And so we are adding moisture from the steam because of gelatinizing the starches. So that moisture is not in the product. That moisture is a surface moisture, basically. And so what I'm doing in cooling is I'm have an airflow over the product, and that airflow basically takes away that evaporated moisture which I added from the steam. That's what cooling, very simple. You do that, there's many different types of coolers, many different types of dryers. Here it says 10 to 11%. This is a horizontal dryer, for instance, vertical dryer, fluidized bed, which we use now for microfeeds, because today we make microfeeds for fish feeds of 0.5 millimeter, 0.8, 0.1 millimeter, and obviously I cannot use bed type, horizontal type dryers for that. This is a horizontal dryer which basically has perforated trays, and normally the dryers were made for drying on the top and cooling on the bottom. So basically you have two passes, a drying and the cooling. I personally prefer to have a separate dryer and a separate cooler because especially lately people make fish feeds, but then they say, hey Joseph, can we also make pet food with that? Well, with a few little changes. And some of the changes are, in pet food, I have to absorb that oil, that coating, that liquid I put on the external of the extrudate of that pellet. And that's the best when you do it when that pellet is hot, because the pores are open and it disappears. And so I dry it, I coat it, and then I cool it. So that's the, well, this wouldn't go any further. I don't know why. Is there any reason why this? Maybe I did something wrong. Well, anyway, I got to stay in my 10 minutes, otherwise Roger is going to, doesn't matter. But the most important thing is that you all understand, and my point was, I mean, Roger gave me 10 minutes, and I give a lot of speeches around the world, and I like to talk for several hours about processing, but 10 minutes is, I just basically would like to make the point how important this is, the flow of drying, and the importance, of course, of drying also is, this is a horizontal bed dryer, and as you can see, the big problem of drying here on the edges, the product is much higher than it is in the center. Well, the air always goes to the least resistance. And the least resistance, where do you think is there? In the middle. And one of the things when you choose a dryer is, what is your variation in the moisture? In any kind of a dryer. It could be a grain dryer. That's really the number one, your variation. Because it could be quite a bit different. I mean, 2%, 3%. I've been to a fish feed plant in Alabama, and they called me because they got a big difference, big variation in their horizontal dryers. And one of the problems is precisely the level of the bed level inside. This is a carousel dryer. They say it got the least variation of moisture. It basically goes from one floor to the other one, and your maximum there's 0.5% of variation in moisture. So that's an important thing, especially when you go into the pet food industry. I'm sure you heard about drying pet food and how many big companies like Nestle and had to actually retrieve their products from the shelves, from the store shelves, because of molding. Well, where does the molding come from? Because of poor drying. So drying, the same with the fish feed, the same with any kind of a product. I mean, poor drying and storing obviously is a big issue. Those are the, then there you got vertical dryers, counterflow type dryers. They actually started out as coolers, which I'm sure, I see there's many people from Holland and Galen and so on. They were one of the first ones to manufacture those type of dryers. And when I was in the management of CPM, we made them together in the United States. So these are the type of discharges, which I also wanted to tell you. One of them is a sliding discharge, and the other one is a tipping or rotating, which I like better because it less breakage. These are counterflow dryers again. This is the fluidized bed dryer, which we use a lot for very small products. Anything which can be airborne can be dried with this. It's floating in hot air. You can control the heat and you can control there's a jet flow there. So basically these are counterflow coolers, which are very common in the industry. Those are round counterflow coolers, and that's about it. So we are at Hall 7 at the US Pavilion and at F50, I think, but it's right on the corner of the main. So thank you very much, and I'll be happy to speak to you later if you need more information.
Thank you, Joseph. That was a very interesting presentation. I'd like to finish it midday because this is the last day of the show and everybody's got things to do. So I want to move on quickly to conditioning, which is another important aspect of the feed milling process. And we're fortunate enough to have Jonathan Sheng from Zhenchang, ZCME from China to address this topic. I know he's loading his presentation now. I think we're recording the presentations here, and on our website later on, you'll be able to access these if you want to share them with colleagues, all the presentations. But let's see how we can move to our next presentation. Why is conditioning important?
Okay.
Jonathan?
Thank you. My name is Jonathan. I'm coming from China, Zhenchang. So Roger, I'm the last one, right?
Not the last one, no.
Okay. I will be quick. My presentation is about conditioning.
Can you speak with the microphone?
Okay. Sorry. My topic is about conditioning. Let's talk about the benefits of conditioning. First one is starch gelatinization. Second, pellet durability. And sometimes when we produce shrimp, aqua, we need a stability in water. And the steam brings the temperature and the heat, this will kill the bacteria and fungi. And because of the starch gelatinization, so it will be less fine in the pellets. And also the steam is like a liquid, so this will extend the spare parts lifetime. And also, if we have lubricant, the pellet mill runs smoothly, this will, of course, increase our capacity. And of course, this is we can reduce our energy consumption. And sometimes, when you have a very low moisture content in the raw materials, you need to compensate the moisture lost. And sometimes the water is money. How many conditioners do we need? Basically, for poultry, for livestock, for ruminants, at least two single regular conditioners we will have to need. If we produce shrimp feed, we will need more. Let's see, previously, this is a configuration of conditioners for pellet mill, for shrimp feed. Below the feeder is, we call it double shaft differential conditioner. It has two shafts. And below one, the biggest one in diameter is hygienizer. And the other two is jacketed conditioner. So we have quite a few conditioners for shrimp feed. Sometimes when we want to replace your current conditioner, especially in an existing feed mill, you don't have enough height. In this case, we will have to use double shaft differential conditioner. This will give you, you don't have the height, we can give you more tumbling efficiency, and this will reduce the height needed. And with this, you can add more liquids, steam into the conditioner. So this is what we used when you have no enough height in your existing feed mill. And from this side, we can see the multiple liquid adding facilities from here. The other type is we call it sanitary conditioner. Some suppliers call it hygienizer, same thing. It has some benefits rather than DDC. The DDC is not first in, first out. This is very important to avoid cross-contamination. And you get stable product temperature. It's controlled by a controller using electricity. Since the gear motor is VFD, so you can control the retention time as you want. You can adjust the speed to fast or low. It's another picture of the condition. There are 4 types of steam. First one is dry steam, wet steam, saturated steam, and overheated steam. Which one do we need? We will have to need the saturated steam. The dry steam has less less water. Wet steam, too much water saturates it, just improper. And overheated steam you can use, but you will need more conditioners to let the heat to generate into the water. If you have overheated steam, then you will have to longer conditioner, or you have several conditioner. If you don't have that, then the steam will just goes into the beans above the pellet mill, and this will make the beans or the hopper bridging or get stuck. After the pressure relief reducer, we don't need any insulation. We do the insulation just before the pressure relief reducer valve. And at least 6 meters to be needed after the from the reducer, from the pressure relief reducer to the conditioner, at least 6 meters according to the experience. So sometimes when you find your pellet mill is choking, the temperature is not going up, then probably you have some problem with your steam system. Whether the condensation cannot be released from the system, or you have a lower quality steam from your steam boiler. That will be my ending to my speech. Thank you.
Thank you very much, Jonathan. I think that we saw the equipment that's available and the reason for some of those components. We're going to stick with conditioning and pelleting focus on process and ingredients when we move to CPM, and welcome Arthur von Hoffer to the podium. Arthur?
Yeah, maybe the mic is
my
also possible.
right here. Sorry.
I hope the computer still works and they fit it.
The USB sticks are
Stuck.
Stick there for later. And then just
Okay.
anyway, yeah, it is interesting because 2 times conditioning is broken, so maybe we think we're going to. We're going to hear double things, but that is not that bad. So, but it is there because conditioning is very, very important for the pelleting process. So we can't emphasize enough the conditioning part. No, this one doesn't work. Oh, that's a pity. So yeah, unfortunately, my lecture starts not very positive because I have to say magic doesn't exist. Some people believe that, some people know it's not true. They have a little bit more life experience, but it is. Like told before, conditioning is the key for the optimal process. And you can select the conditioning. We already heard 1 conditioner, 2 conditioner, there is even more. And if you don't select the right conditioning process, it's going to be very costly for you. So, we know why we need to condition, we just spent 10 minutes on that. But what is conditioning? Conditioning starts by grinding. The first step in your conditioning process, in preparing the product for the pelleting, is grinding. I'm not going to discuss that. That is already done by my colleague. Thank you for that. But we're going to be a little bit deeper in the technology of conditioning. It's one side thermal and the other side is mechanical. Thermal by adding steam, mechanical treatment by electrical energy, how we measure that, by netting, shearing, compressing. The type of conditioning is based on the characteristics of the material. The starch, the fiber, the fat, they all have their optimal, unique way of getting processed. And this one is basically the most important sheet if you look to conditioning. What does that mean? If we have a high starch formulation, we take quite a lot of thermal energy and not so much mechanical energy. The more we move to higher fiber, we're going to start to add more mechanical energy. We're going to use less thermal energy, and even when we go further, we're going to increase again the amount of thermal energy, but the total energy processing is going to be much higher. And for every step in that process, there is actually an ideal way of doing that with different type of processes, which we highlight a little bit. So we start with just the simple steam conditioning for higher starch formulations. I heard already saying that you have to prevent that steam going up, it's superheated. But another thing in the design of your machine is very simple, of course, electrical energy by a direct drive. But there is also a possibility to have we call it a dynamic steam lock in your conditioner, preventing that the steam goes up. If you want to know more, you can come to the booth of CPM M058 in Hall 8. We skip this one for the time. But there are different ways of adding your steam optimally in the machines. We heard already about more conditioning, because the more fiber you get, the more mechanical quality you want to put in. They want to longer conditioning times. How they started to do it with double conditioners, or if you want to have a higher liquid, people put an extra conditioner on top, and after that put a conditioner below to have enough retention time, and on top the high-speed conditioner. But that is not necessary anymore. Those 3, 4, 5 stacked conditioners are only there because the traditional conditioners have not enough retention time, have not enough filling. So when we were looking in finding ways to get a more hygienic conditioner, we found out that the higher the filling you do, the more clean the conditioner stays. So we find a way to increase the filling degree to 70%, while a traditional conditioner, everybody says 30%. Well, if you look in the field, you maybe sometimes find as low as 15%. So when you go to 70%, that means at least 2-3 conditioners would be the same in the traditional one. So that gives all the benefits of a higher temperature, you have a better pellet quality, your hygienization, etc. How does that work? Because I say magic doesn't exist. Actually, the trick in there is that the pedals, the tip of the pedals are transporting the product to the front of the conditioner, while the shafts of the pedals are transporting the product to the rear. How does that come? Because the shafts, the pedal shafts are mounted in a spiral way, and the direction of the spiral is backwards. That means that the product goes forward, backward, and stays in, and you create so a longer retention time, but what is more important, the liquids are sort of polished by the material inside the product, so the absorption is much better. And then, last but not least, at the end of the line, when you finished your product, it doesn't look like this, the traditional one, because what happens is people like to increase the retention time by putting the pedals nearly, how you call it, square against the wall and not covering the wall. Here you see that the pedals are parallel to the wall. That means that they can clean it. And this is really true. This is not from the workshop. This is how the conditioner looks after a run. It's really amazing. When the first time the mechanic came back, the engineers came back after commissioning, they saw this picture where I don't believe it. I came to my customer, I opened the machine, and it looked like that. So they were not fooling me. One little thing, when you start, you want actually as quick as possible to go to your set point temperature, because then your pellet mill is operating ideally and it's more hygienic. How does it work? First, the conditioner goes in reverse. Then we add steam till it reaches the temperature and we change the direction. So that means that the first kilo coming to the pellet mill is warmer. But what does that mean? That the pellet mill reacts completely different. You can go in 2 minutes to your set capacity. And with all the frequent changeovers we have, it means an enormous benefit. Especially also when you do hygienic feed, because the first kilo coming to the hygienizer needs to be warm already. So an hygienizer is not a very complex thing, it just needs to be built correctly to keep it hygienic. But it is just a big screw, product goes in, first out, and depending on your RPM you can go to the end. So that brings us a little bit to the pellet mill. And yeah, the pellet mill we can also be quick, short. It just needs to run needs to run, make good pellets, because a pellet mill operator doesn't like to do hard work. It does certainly should not slip. So, but we were talking about energy. Okay, so. And energy must be consumed most efficiently. And we as feed millers have a responsibility to go to a sustainable, more sustainable world for our children, our grandchildren. So we need to provide the industry with the most energy efficient machinery. And we do that, of course, with gear motors to reduce the footprint as good as possible. We're talking about that energy. In the pelleting process, we have different materials we process. And each material has a certain amount of thermal energy and a certain amount of mechanical energy. Just like, for example, each product needs to be ground on a certain particle size. So the thermal energy you can adjust easy in the conditioner, while the mechanical energy you have in the die, and with a roll adjustment on the pellet mill you can start to adjust the amount of mechanical energy to put the optimal energy into the pelleting process. It's actually a very simple possibility to adjust the gap between the rolls remotely during production. It increases your pellet quality, I will show you. It increases your die life, it reduces your downtime and increases your safety. But here is what it really is. Here you see, by increasing the roll distance, you increase the amount of kilowatts. And with that, you increase the quality. So, by adjusting the roll distance, you increase your quality, or you adjust your quality. And that is very important. Now, of course, we all know, or the real pellet mill operators all know, that the pellet mill is operating optimum just at the moment before it starts to choke. So now the trick is, how can you find that point? The other thing is, with the linear roll adjustment, you say, yeah, nicely, but I don't want to damage my die because I need to know where my die is. So we have a solution for that with measuring the speed of the rolls. Because when the speed of the roll is the same as the die, there is no slip, we know it's touching the die, it's 0. But as soon as you go a little bit off the die, there is a little bit of slip. And that means that there is no steel-to-steel contact, meaning that your die life is much longer. And how that looks like, see here. So this is the 0 point, and the RPM goes up when we increase the temperature. And at a certain moment, you see that the roll speed is going down. I say, oh, we should not go higher in temperature, because if you would go higher, but one roll will stop. Then the next thing is that you can play with you stop with the temperature, 78 degrees, and then we start to play with the roll distance. And you see that you can control nicely the slip and keep your pellet mill at the optimum point. Talking about dies, I see so many times when I come into a feed mill, the feed miller say, solving his problem of pellet quality by just buying a thicker die. But the thicker die is a curse. It's very sensitive for slippage. You can have less steam addition, meaning with that it reduces your capacity. You get your higher wear cost, your higher energy cost. I give you quite an interesting calculation here, what you can sometimes find in the feed mill. So when you run optimally, you run, for example, at 80 degrees with the 12 kilowatt hours per ton energy input, meaning that you have not so much. You have steam costs, but they are not very expensive, and you have limited electrical costs, but they are expensive. When we do it, for example, instead of the 80 degrees, we go to 55 degrees, you see that the steam costs are reduced, but the energy costs, which are much higher, they are increased, meaning the total costs are increasing. And that is not all, because what is the result? On the let's say the ideal situation, the capacity of the kilowatt hours is 12 kilowatt, but it means that your capacity of your pellet mill can be 21 ton if you have a 315 kilowatt machine. But if you reduce your steam, you consume more energy, meaning that your capacity goes down. So at the end, you run on a very low capacity with very high costs. And with that high energy, you also increase your maintenance cost. And this situation you see happening in the field. Then you're running with a too thick die, you maybe have not the optimum conditioning system there. Talking about dies, people run with the dies till they really are worn. But the economical lifetime of a die is much shorter. Here, look what happens. You see the price of the die, which is very small, goes down, down, down. But the energy consumption of a die in a lifetime goes slowly up, meaning that the total cost of the die also goes up, meaning that your economical life is shorter than your technical life. So people, feed millers, don't be penny wise but pound foolish. Change that die in time. Talking about that, even worse is your roll shells. The roll shells are very low cost compared to the expensive die. But what do people? They damage their die with the short rolls, with the cheap roll shells, because running too long. One quick way before we go slowly to the end. Talking about rolls, rolls typically need to be greased, but grease is not nice to handle in a factory. You have to store the barrels, you have to go to your automatic greasing system, you have to fill that greasing system, you have dirty hands. It is really a disaster grease. So we offer you the possibility not to use grease anymore, because we have grease for life rolls. Those rolls are filled with a little bit of oil. Oil has a better lubrication characteristics than grease anyway. So really the future, and it's also hygienic because the grease doesn't end up in the feet. So we had the linear conditioning, but if pellet quality still is a problem, and you have, for example, a very high fibrous material, you use very thick dies, and still you have no quality, there are other solutions. One thing, and I'm not saying that because I'm selling pellet mills, is double pelleting. It all depends on your formulation. In Holland, England, Ireland, Belgium, you can find a lot of double pelleting installations, because we have the entrance to a lot of raw materials. Grains are nearly gone in the feed for cattle and dairy, and in this way, double pelleting is a solution, because if it's hard to do in one step, you can do it in two smaller steps. No thick dies anymore. Back to thinner dies, increase flexibility, and much easier pelleting parameters, using low-cost ingredients, creating lower production costs. So we went through this story of the different conditioning processes and the pelleting, and then we coming to this pre-compaction side, and basically the last thing is in the area where you have very high quality demands, you also use a lot of energy. For example, pre-compacting with an expander. An expander is a shaft which is transporting the product to the front, and a cone who is stopping it, increasing the pressure there. Now, what I like to realize, everybody, is that if you have a feed where it is very hard to get energy in and very hard to make a good pellet quality, then on normal pelleting you will end up like here, less energy but also lesser quality, while the expander pelleting can have a better quality but also using much more energy. Because if you see in ratios where it is easier to process, where you can still make a quality with a normal pellet, you see the difference. The qualities are the same, but the energy on the pelleting process is much lower than on the expanding process. Much lower than the expanding process. So the story is, and that is basically the story of my whole presentation, you have to use, you can use the expander to improve your quality, but you have to use it on the right, right formulations where it is hard to get energy in. Because if you do it on the wrong ones, you have higher wear cost, less controllability, and it's less user friendly. And of course, the first step, if you want to add fat, is not buying an expensive expander, it's to put a post-pelleting fat coater in. So that basically brings me to the end. There is not one solution for all in conditioning. You have to select your system based on the properties of the material you're processing and what you want to do with it. I always say, hey, what works for him doesn't necessarily work for her. And yes, if you make the incorrect solution, you end up paying too much. So thank you for your attention. I think if there are questions, you want to do it now or you want?
Thank you very much.
Okay, thank you, thank you. It was a pleasure.
Thank you, William. Thank you very much. Assalamu alaikum. Thanks for this opportunity. Yes, as you said, I am the CEO of ASM, and we are responsible in feedmill solutions industries for over 16 years. We'll talk a little bit about things. I'm sorry, I am the last. I know lunch now, so bear with me, 5 minutes. Inshallah, we finish fast. And yeah, so basically, a small topic about your automation limits, where you want to be in automation. How far can you go? So it's very important to understand the human artificial intelligent interface. Where are we going? The robot-human interaction. Where are we going? With these things is very important. Number one, you should be really thinking of a base platform that you can always change anytime you want. You should not be industry specific. You can always switch it, modify it. Don't lock yourself. This is really a very common mistake when we go into artificial intelligence or robots or automation. And why we do this? So, of course, you increase your performance. That's number one. As my colleague William was saying, the interface of error interaction with a human. And number two, cost reduction. We always think how to make more money, less cost. Reliability, because if we always have sustainability, reliability, it also makes production much easier and safer. And at the end of the day, your quality has to be strict and stick to the certain quality procedures. Okay, going to smart devices now. I think we all have smartphones, smart watches, and all this collect data. So these all things which collect data. Your washing machine sometimes is needed to be connected to update, your microwave, your clock, your mobile, all these, they call it Internet of Things. And with Internet of Things, you are able to gather information. And based on this information, you are able to produce better, different ways, and you analyze it for market, as my colleague William was saying, into analytics and artificial intelligence. Other things, before you keep proceeding, you need also to increase the skills. So the electrician is not anymore a normal electrician that looks into 24 volt, 220 volt, 380. You have also to link with him the idea of having some information on communication, IT stuff. So it's very important to improve. You can always buy a Rolls Royce or a Ferrari, but if you don't know how to drive it, stay with the Corolla. So you have always to improve yourself in these things when you are going into latest technology. Other things which I saw common mistake in this area where we link directly. So you can see we have a two interface. IT is the IT network. OT is the operation network and the operation technology. So it's always very interesting to not let somebody from outside can go all the way to your sensors, to your machines. So it's very important to keep always having a certain update on firewalls, cybersecurity, because all this, it's getting dangerous once you're on the net. And some companies, they still fear to be always having on the net stuff. However, it's going to come. You are going to face an era where you will have to be always connected on the net. It's coming. As now mobile, you always have a camera. Certain periods were saying, no, you enter mobiles, I want a mobile without a camera. So it's the same thing here. We have to be ready and always updating stuff like that. The same way of just showing it as a firewall here. So to have a certain ways of connectivity to updating to your analysis of your plant. We do this because we are going into something called real-time analysis. When I monitor, when I plug it in dashboards, and this is very important because with your 24/7 analytics and checking, computing, we are running into an industry called 4.0. So all our automation technology now is driven with industry 4.0. With this tells you that you have to have real-time analysis. So I can know immediately from the store how many X production is, how many maintenance running hours of this machine immediately on the spot. Otherwise, it's useless to have something called automation now. So automation is improved. It's not anymore you run the plant, I am automated. This is now the basics. I want to have a certain information on the spot, and this is called automation. And this is called Industry 4.0. Do we understand? So yeah, cloud computing. What I said previously, the challenges of this cloud computing, you have to be careful on how far I can go from the net to the plant, because it's always going to be hacking, checking information, stealing information. So this all need to be addressed in a certain way, but you will still need to do data collecting. I come from Saudi, I will connect oil. Data is the new oil. So you need to understand this now. All information gathered is the data, and based on the data, you can go out to produce a better output on that. So yeah, in the engineering side, we are Siemens guys, so we do Siemens solution softwares. So in the engineering side, most before, let's say we do installations. We have to install a server. Most of this now is going to go on the web, which means you need to always have a connections. So there's no more something standalone. Okay, maybe there is still, but in the 5 years coming up, this is going to be a different way. And because very important to have the communication, which I said previously, the real-time analysis, where we need to know proper information very fast to compute and to analyze and to do certain ways, because data is the new oil. So yeah, the end up of the dashboards, the KPIs, you will end up with stuff like this. Numbers is really good, but to show for managements, they like to see it in charts, where you are green, red, yellow, whatever. So then they can immediately understand. So dashboards, it's mostly designed for managers, high level, C-level, let's say CEO, CFO, in production teams, somewhere where they can really understand what's going to interfere in the next month, quarter, whatever. And yeah, challenges, you will always have the skills, the connectivity on the internet, the firewall updates, stuff like this where we will start having. So it's not anymore a normal electrician, a normal automation. This is all going to be linked together to give you a better understanding. Yeah. Easy, 5 minutes. I hope I did it. Thank you very much.
Number one, but number two, giving us an insight of what the future holds for us. And I, for one, think we have to embrace it. I've got a little video camera here that, just a few years ago, you had a guy with a big thing on the shoulder, lights, everything like that. In our industry, publishing industry, everything's changing. I don't see why in the feed industry we should hang on to the past. We should grab the future. understand what is happening and engage with companies that the Tony's talked about represents in order for us to stay up to date with our industry compared to other industries as well. So we want to keep abreast of developments. But right now, we've come to the end of our presentations. I know we've gone over time slightly, somewhat, but I'd like to, some of our speakers have returned, so there's an opportunity to ask questions. We'll just take a few questions, be brief. If anybody has a pressing question or a comment, I'm happy that you make a comment. And how do you feel about what you've heard? Is there anything that's a standout for you? Is there anything that you'd like to have clarified? So, anybody like to get the ball rolling? While you think about that, and I won't let you off the hook, I'm sure we all have a question in us. I'd like to say, or comment about, where is the future of our industry in terms of technology? Are we really grasping technology? And I'll mention it in terms of enzymes. We know enzymes improve some of the raw materials we use in the diets that we're producing. Yet there are some countries that have taxes on enzymes coming in. There are some companies that don't use enzymes. We're not getting the best out of our raw materials. And I just wonder if automation, technology, if this is happening, is there a resistance to technology, do we think? Is there a resistance to change? I'd be interested if anyone here would like to comment on that. But I see in my industry, there is a resistance. Yet those who jump too far, too fast, take a huge risk. And there are magazines in our sector that are disappearing because they have overstepped, in my view, have overstepped things with digital technologies. However, where is the middle ground? Do we launch ourselves into a future, or do we take it one step at a time? Joseph.
Well, Roger, I suppose my words are from the past, but I'm in this industry for 55 years, and obviously, but I still believe today. I don't think there's a resistance against the technology, against automation. I mean, I really like that. I forgot to take a picture of that oil, the day that compared to oil. That's a good one. But in the feed milling industry, there's still the human. I mean, you can't automate. That's just, my wife is a great cook, but I don't think she could automate the kitchen, and I don't think I want to eat what the automation from that. So, you go to pelleting, and you still need to test of the durability. Yes, we have durability testers, yes, but go to extrusion, and I still want that product coming out of there, I still want to see what the density is, and and so on, what the moisture is, and so there's still a lot. Basically, with technology, like this gentleman just said, you could sit in your living room and run this feed mill, no problem at all. I mean, technology is there for doing that, but I think it still needs the human part of making a quality product. So that's my opinion.
Thank you. Anybody have a similar view? Have a slightly different view?
Actually, I travel quite a lot in Africa and Middle East, and actually, I've seen also quite some females in Europe. As I think Africa is actually leapfrogging. Sometimes they are just skipping some steps, and actually, I think Europe is too conservative in that field. Because we stick to certain habits, we stick to certain things that we know, while actually technology is already further. And in this region, the African region, they take a step that they need to take, and they take it faster. It's not only in feed milling, also in some other, like if you look at mobile money, things like that. They just go straight to the good solution.
A very good point. A very as we should be? Is there something we should be forcing, or not forcing, but promoting more, that we protect our grains more?
Yes, Roger, I feel we should have, here I spoke about grain management, but here you see the picture. We need more plant management. And we have two situations. We have to look about the cost, look about the quality, and more are not so many people with know-how in the plants. So get what Ali said, ISM, the company, do the right control panel for all the plant, and then you get at the end a good quality and a good product and save cost. What ISM is doing, I feel this is very, very important. Here, today we saw there are many very good equipment. All what we hear in the morning, good equipment, but with the control panel, total amount more. This is very important, and this is also range management, what I said in my presentation.
Thank you. A comment back here.
Hello, yes, I'm Richard Altman. I actually started my first job in a feed mill at the age of 8, when my father asked me to go and clean Hessian bags. So that's 64 years ago. And I've been a farmer there ever since around the world. My general observation is that the feed mill makes what I would call a lot of one-off decisions. You choose your machinery, it has to last a number of years. You choose a grist size, according to what animal you're feeding. You choose a die specification that will last you for several thousand tons. The area of concentration in a feed mill that the production will have control over is the conditioning. It is the hub of the process. And sadly, in such a high percentage of the feed mills I've ever visited, and I counted up the other day, it's nearly 1,300 feed mills, the steam is not in the correct condition. It's been alluded to by different speakers in terms of what's needed, but not enough attention is paid to the condition of the steam, the temperature, the pressure. It was mentioned that there should be a distance of at least 6 meters, but when you reduce the pressure of the steam, you expand the volume. So the pipe size is critical, from the reduction valve to the conditioning. So my plea to the industry is steam should be considered with the same priority as a feed material. Day by day, shift by shift, attention. Because with good quality steam, you get good PDI, you get good tons per hour, and you get a good economic performance for the mill, and you're delivering that to the farm as well.
Thank you. But can I ask Richard a follow-up there? Do you think that we ignore steam because we're not measuring something?
Yes, and you know, you have a guy somewhere elsewhere in the site who's looking after the boiler and the treatment of the water, and steam just comes in from perhaps right field, and the guy operating the press hasn't got time or doesn't consider about the steam.
Or hasn't been trained for
Or hasn't been trained. And when I ask somebody on the production side, what is the temperature of your steam just before going into the conditioner? 90% of the time they'll say 80 degrees. And I say, no, that is the conditioning temperature of the mill, not of the steam. It is critical to know the pressure and the steam temperature. They're interrelated. And your performance will be governed by that.
I think that this is an example of, I think, where we miss some points, and I think it's the digital technologies or the future of the cloud. It's not data, it's measuring things, it's recording things. I mean, we call it data, but it's doing more than just data. And I think until we can see the impact of that on our cost of production, on the quality of production, that we can see by tinkering, by changing things, or by replacing the die, looking at the rollers, until we can measure that, I think it's a bit identify where all the problems are. I think we desperately need digitalisation and the cloud and automation and making our machines, for want of a better word, smarter. And any other questions from our speakers?
Just a small reaction on the steam, because you're right, people are not measuring. Now, unfortunately, it's not so easy to measure, because if you measure the temperature of the steam, doesn't say you anything, because the condition of the steam you can't measure with the temperature, because it can be saturated, it can be wet, it can be partly wet, etc. There are nowadays perfect systems to measure the quality of the, but they cost a little bit more money. And the industry, unfortunately, don't realize that how important it is. And I think that's also, we keep on telling it, we keep on offering it, but at the end, they buy this low-cost steam line. Even sometimes they try to design it themselves. What you can find in plants is terrible.